is really a summary of what we want to do. And I don't want to repeat or read out what's on that chart. I just want to make what I think is really, really one important connection, which leads us right to this truck that you see over here. Because for everything that we've said about technologies, future technologies, or also today's technologies that you can already see here in this hall, battery, electric, exactly, hydrogen, etc. I think it is also extremely important to bear in mind that even with today's existing internal combustion engine framework, we can already, through lubrication, through aerodynamics, etc., we can already make an important and very, very measurable contribution to reducing the CO2 footprint, which is extremely critical if you look at the recent ICPP report that we were referencing earlier this morning, which really is a red alert, as Eric called it, for the planet. So just waiting for technology to kind of scale up and permeate through the system is not going to be good enough. We've got to be working on what we have today with the tools that we have today. And this is what the Starship trucks actually literally embodies and shows and demonstrates. It's meant to demonstrate. I'm very, very pleased that, in a second, my colleague Zelda will actually reveal, who is much better at this because she has a much deeper understanding of the actual technological aspects. And she will reveal what I think, I've had a sneak preview of the numbers, she will reveal what we can actually do today in terms of energy consumption reduction, which I personally think is absolutely fascinating and is one important tool in this toolbox that we're talking about. I will finish by saying that, as you would expect from a company like Shell, we have our own, in addition to providing the infrastructure that I was talking about earlier, and in addition to driving and provoking the thought change, the thought leadership also on things like Starship and reduction today, we also have to do our homework as far as our own distribution is concerned. As you can imagine, a company with 45,000 retail sites globally, as an example, has a lot, or puts a lot of traffic on the road, puts a lot of road transport into it. And therefore we also have an obligation to reduce our own emissions very practically. So it's very, very important homework that we've got to do. You see it here, that we want to reduce on average by 30% by 2030, which is a tall order and obviously not something that we can just do by ourselves, but we're working with our hauliers, our partners in this space to do that. But it's an important contribution and also recognition that we're in this together, and it also concerns ourselves as shippers in this case. But without further ado, I would now like to actually hand over to my colleague Ryan, who, before we come to the numbers and the actual revealing of the results, which once again I think are impressive, but you will be the judge, will talk us through what Project Starship is actually about and how it works in more detail. Ryan, can I welcome you?
Thank you. Hi everyone. So what Patrick just talked through was some of the challenges that we're facing in terms of increased energy demand and the whole decarbonization journey in freight transport sector. But what I'm going to look to talk to is touch on some of the solutions like Starship that help move us closer to meeting those challenges. So you see the mission statement of Starship 2.0 at the top there. To go farther using less. So what does that mean in the context of Starship and specifically in freight transport? Effectively, what we're trying to do is encourage or promote a behavior in this industry where you look to carry the maximum allowable payload using the least amount of energy per goods shifted. So we want to do this using the most advanced and currently available technologies today, and we want to ultimately maximize on our freight ton efficiency. And I'll expand on this now. So what are Starship's guiding principles? To basically understand this concept of freight ton efficiency, we have to kind of take a step back and look at the design ethos that went into the making of Starship 2.0. So don't be discouraged or disheartened by this formula. Effectively, freight ton efficiency is the truck's fuel economy multiplied out by the mass of cargo being carried. And that metric is expressed in ton miles per gallon. Now, to fully understand this, you've got to look at the variables that affect this metric, because if your overarching objective is to maximize on freight ton efficiency, then you really want to kind of focus your design on 4 key pillars. So with that, if you look at opposing forces, I'm talking about things like improving aerodynamics, reducing rolling resistance, reducing your base componentry weight, because ultimately you want to strip down your base setup to its, utilizing the least amount of weight so you can go as heavy as possible. Then we look at things like energy conversion, so your tank to wheel efficiency. And when I talk about that, I'm talking about an optimized powertrain, reducing the parasitic losses between the engine and the transmission, using things like low viscosity lubricants to reduce your overall friction in the system. Encouraging a steady driving style. So in the whole design philosophy, this is a big component of it. And with driving style, we're talking about things like removing variables like unnecessary braking and acceleration. So to that end, we've included a lot of in-cab devices that promote a steady style of driving. And then finally, ultimately, the heart of freight ton efficiency, maximizing on payload, okay? So with that, with the guiding principles in mind, let's take a look at some of the technologies featured on Starship 2.0. At its foundation, we have a lightweight International LT chassis. This is a Meritor Fuel Light Plus 6x2 configuration. We've gone with this to allow us to optimize on our weight, and to basically it offers us a better fuel economy and basically reduce friction throughout our design. Now, I mentioned rolling resistance in the previous slide. It plays a critical component in tire selection. Across both tractor and trailer, we have Michelin's energy efficient tire series. And we've chosen these because of their specially formulated tread compound. They essentially reduce heat resistance, or and increase durability. They're lightweight. So it's in keeping in that whole design philosophy that I mentioned above. At the heart of Starship is our optimized powertrain, right? And this is our Cummins 2020 X15 next generation engine. It's paired with Eaton's Endurance transmission. And this integrated pairing of engine and transmission offers us that improved fuel economy, that reduced greenhouse gas emissions that we're looking to do. Moving into the engine, if the powertrain is the heart, then the lubricant serves as its lifeblood. So in the engine, we have Shell's Rotella T6 Ultra 5W30. It's a FA4 oil, fuel efficient oil. Paired with this is Spyrex S6 GXME 75W80. This is our fuel efficient gear oil that's designed to meet the protection and performance needs of heavy duty gearboxes. Taking a step back, if we start to look at the exterior features, and let's start with the trailer. At the back of the trailer, we have our custom bow tail, and at the top we've tried to be as enterprising with real estate as possible, and we have a 5,000 watt solar array that sits on the roof of the trailer. So we use this to kind of offset the engine load. So this is used solar, we're harnessing as much of the solar energy as we can to power some of the auxiliary systems in the truck. And now moving on to the only piece of hardware that we've retained from the original design, that's our aerodynamic carbon fiber cab. We've done this because it works so well on the first truck. It proved so aerodynamically efficient that we felt we didn't need to make many changes on this. So to put it in context, the coefficient of drag on that cab that you see in front of you is around 0.25. If you compare it to a traditional base tractor or conventional base tractor, that's 0.6. So it puts in context that, Starship is more than half the aerodynamic drag of a conventional tractor on the road. Moving from the back of the cab to the trailer, we've included our automated gap panels from Truck Labs. Now, what this does is allow us to maintain the aerodynamic benefit we gain from the unique design of the cab. So as it keeps the flow of the air basically straight along, transitioning from the cab to the trailer, and I'll show you how that looks now in a moment. At the back, I mentioned this custom bow tail. So studies have shown that this, in concert with additions like your full-length side skirts, can result in fuel savings of between 1 and 5%. Now, if you add things like the side skirts, the custom-made automated gap sealer, and the cab, you're looking in the range of a 20 to 25% aerodynamic improvement on this base setup alone. Now, when all of this is working in unison, what you have is, compared to the average truck on the road, is the profile of Starship ensures that the smooth airline flow from bumper to trailer across the body. So we don't have this incident air that breaks away from the body of the truck. And that's basically giving you a fuel economy improvement. I'm going to pause there now because I'm excited to share with you guys a video that basically details or showcases the truck under real operating world conditions.